Namaste everyone. So in this video you are going to learn today the same chapter, that is Introduction to Trigonometry, 5th main. So in the last video, as you know, I completed exercise 8.4, 4th main, and in 5th main there are 10 questions. We completed 4 questions. So today I am going to start with 5th main, 5th question. So before I start, let us recall the 3 identities, very important identities which we are working out because of 3 identities we have in exercise 8.4. So what are the 3 identities? First one is sine square a plus cos square a equals to 1. And the second identity is 1 plus tan square a equal to secant square a. And the third identity is 1 plus cot square a equal to cosecant square a. So keeping these 3 identities in mind, so let us start the 5th question in 5th main. So what he has given, verify cos a minus sin a plus 1 whole divided by cos a plus sin a minus 1 equal to cosec plus cot. So as already told you, I cannot prove the simple to complex. If I take a simple statement, I cannot prove it as a complex. So better to take the complex statement, whichever side is as complex, that side you have to take and prove the another side. So here you can just clearly you can see that left side is complex. So what I am doing now, divide the left hand side by sin a. So why I am doing this? If I directly take one as identity 1, that is sin square plus cos square, there I cannot further use any identity, algebraic identity to get the cosec plus cot. So because of that, we are dividing the left hand side each term by sin a. Why? When I divide, you can see when I divide cos by sin, you get cot. Cot is there in RHS. And when I divide 1 by sin, you get cosec. You can see the cosec also is there in the RHS. So to get the terms in the RHS, first let us divide all these terms by sin. Then later we will see what happened. So the first one, now divide LHS by sin a. Observe the LHS and write LHS after dividing what happens. Cos by sin becomes cot a. Next minus sin by sin is 1. Plus 1 by sin is cosec a. Whole divided by, again, cos by sin. Cos by sin is again cot a. Plus sin by sin is 1. And minus 1 by sin is cosec. Now let us rewrite this so that 1, if I write that side, because I am using here trigonometric identity, for that sake 1 let us write at the last. So cot a plus cosec a minus 1 divided by cot a minus cosec a plus 1. So nothing I did here, just I rearranged the terms. Now what next? So you can see the RHS, you don't have any denominator here, you have numerator. So from that you can get an idea that here the denominator should vanish. If I want this denominator to go away, the numerator also I should get the same term what you have in the denominator, so that I can cancel. So for that, let us take use this 1 as one identity. You can see that there is one identity which is involved with cot and cosec. Just recall, we know that 1 plus cot square a equals to cosec square a. Now this you can rewrite as cosec square a minus cot square a equals to 1. You can see now this 1 can be written as cosec square a minus cot square. Again you can observe this is like a square minus b square. Here I am using 2 identities. One is trigonometric identity. After using trigonometric identity, you can see the algebraic identity. What algebraic identity will suit here? It will be like a square minus b square equals to a plus b into a minus b. So this is 1 plus cot square equal to cosec square a. Cosec square a minus cot square equal to 1. To replace 1, you have to replace 1 by cosec square a minus cot square. First let us do that. So this equals to, write cot a plus cosec a as it is minus 1 you replace with that identity. What is that? Cosec square a minus cot square a. Whole divided by, write the denominator as it is. So that is cot a minus cosec a plus 1. Now you can observe this is like a square minus b square. So I can use now identity as a plus b into a minus b. In place of A you have cosec and in place of B you have cot. So let us rewrite this bracket again into algebraic identity. So now write these terms as it is, that is cot A plus cosec A minus, now this bracket you are rewriting using algebraic identity, that is A plus B into A minus B. So what happens? A plus B into A minus B, that is cosec A plus cot A into cosec A minus cot A. You can observe this is like A plus B into A minus B. So I have written this A square minus B square as A plus B into A minus B. Whole divided by, write the denominator as it is. Don't disturb the denominator. Denominator is cot A minus cosec A plus 1. So cot A minus cosec A plus 1. Now, what next? We use here, in place of 1 we used trigonometric identity and in place of trigonometric identity we used algebraic identity. Now, what can be done? Your goal, your intention to get the denominator in the numerator. So same denominator if you get in the numerator, you can cancel it. So your answer is cosec plus cot. To get that, what I can do? You can see just here, this is your RHS. It is ready already. Cot A plus cosec A is itself is your RHS. So the letters you can see here, cosec plus cot, cot plus cosec, both are same. So that bracket you remove, I can write it as cot A plus cosec A. If you remove this bracket, in this nothing is there, means it is understood 1. So don't write 0 there, any number into anything is same. So you get 1 there. 1 minus this bracket and this bracket is already removed. Bracket is removed as a common. So this you no need of writing here and here into is there. So 1 into any number is same. So no need of writing 1 in place of this bracket. Now write what is remaining. Cosec A minus cot A is remaining divided by, write denominator again as it is, cot A minus cosec A plus 1. Now almost we are at the end. You can see now, this already said that cot A plus cosec A is itself is your RHS. Then what about these two? These two should get cancelled. You can see now cot A plus cosec A. Now simplify this, 1 minus cosec, minus into minus plus cot, whole divided by, write this denominator as it is, cot A minus cosec A plus 1. You can observe this trinomial and this trinomial, all the same, but terms are reversed. They are not in order. You can see plus 1 minus cosec plus cot. So this trinomial and this trinomial gets cancelled. What is remaining? This equals to cot A plus cosec A. So this nothing but RHS. So we proved, we have taken LHS and we proved it as RHS. Hence it is verified. Now let us solve example 15. I already said you that fifth main question number 5 and example 15 are almost same, and working out whatever the steps you are taking, almost both are same and both questions are very very important. So I am doing example 15 also. But in your textbook they are given in another method, but I am solving in a easy method. Just you can observe. Now you can see the left side again. There in the fifth question we divided LHS by sine. Now here I am doing divide LHS by cos. Why? If I divide cos, you can see sine by cos is tan. So tan is there in RHS and 1 by cos is sec. The terms are there in the RHS, so I am dividing. Otherwise, you cannot take 1 as like you don't have any relationship. If I take sine square plus cos square also, it is like a square plus b square. There is no identity with a square plus b square. So I cannot replace 1 by first identity. So I have to convert this sine and cos terms into second tan terms. So how you get that? By dividing each term by cos. Now the LHS is rewritten. Sine by cos. Each term you divide. Sine by cos is tan. These all you have to remember. The reciprocals, the ratios, and also the some key points which I have discussed in the first video. So tan minus cos by cos is 1 plus 1 by cos is nothing but sec, because cos reciprocal is secant, divided by sine by cos again is tan plus cos by cos is 1 minus 1 by cos is sec. So as you can compare the previous question and this question, same, almost procedure is same. Again you write this 1 at the last. So tan theta plus secant theta minus 1 divided by tan theta minus secant theta plus 1. Now, in the previous question, I replaced numerator 1 using 1 plus cot square equal to cosec square. But here I am not disturbing the numerator, I am disturbing the denominator 1, because you have here denominator terms. Numerator nothing is there, 1 is there. So, for that sake, the numerator term should get cancelled. Keep in mind, these are all you have to recall again and again. See, directly this is nothing that every question has same procedure. Every question is different in this concept. In identities, related to identities. That's why should be very careful. You have to see the RHS. According to the RHS, you have to go on simplifying the LHS. So now I don't want anything. This should get vanished. The numerator should get vanished. To vanish the numerator, we have to make 1 here 1 as the another identity which is related to tan and sec. So recall what is the identity which is related to tan and sec? Yes, 1 plus tan square equals to secant square theta. So this can be rewritten as secant square theta minus tan square theta equals to 1. Again it is like now I am using here trigonometric identity. After that again you have to use the same step which I have done in the previous question, that is a square minus b square. Now this can be written as tan theta plus secant theta minus 1. Numerator don't change here. Denominator, write tan theta minus secant theta plus 1. In place of 1, you have to write that as secant square theta minus tan square theta. Secant square theta minus tan square theta in place of 1. So we got till here. Now 1 is converted to secant and tan. You can observe here this secant square minus tan square is in the form of a square minus b square. You can write this again as a plus b into a minus b form. So now here you write this numerator again as it is, tan theta plus secant theta minus 1 whole divided by, write this also as it is, tan theta minus secant theta plus, use identity, algebraic identity, secant square minus tan square can be written as secant theta plus tan theta into secant theta minus tan theta. So now this is replaced as a plus b into a minus b form. Now again same what I did in previous question, I have to take something common in the denominator. What is common? Just observe here tan minus sec is there. There you had cot plus sec, sec plus cot. Suppose if you have with plus sign, however if it is cot plus cosec or cosec plus cot, both are same. But here you have minus, tan minus sec, sec minus tan. You can see this binomial and this binomial looking like same but in the reverse way, and you have a minus in the middle. If it is plus nothing, don't worry, plus if it is plus nothing to take common, you can directly take common this binomial. But here I cannot take tan minus sec common because you have there sec minus tan. So for that I have to take one minus common so that it will be same. Numerator as it is tan theta plus secant theta minus 1 whole divided by, here I am taking minus common. Why? Why I am taking minus common? If I take minus common, this plus tan becomes minus tan and this minus sec becomes plus sec. So that you can just now you can see it is like secant minus tan. You can see secant minus tan. Both are same now. So now plus this write as it is secant theta plus tan theta into secant theta minus tan theta. Why I have to take minus common here? Why not here? Why? Because you can see the RHS has secant minus tan in the denominator. So I need this term only as a common. So for that sake, so write numerator again as it is tan theta plus secant theta minus 1 whole divided by. Now what you want to take common? Yes, secant minus tan, secant minus tan. Now you can see this term and this term is same. Even the sign is also same. So take that common. Secant minus tan. You can observe the RHS. Same term you have in the RHS denominator. Secant minus tan. So now open the bracket. Here in this bracket beside you have minus. So this bracket only I have taken common. So what is remaining here? Nothing is there means already told it is into 1 with minus. So you can write here minus 1 plus bracket open and there is plus here. So no need to worry. Write as it is secant plus tan whatever it is remaining. And this bracket already we have taken common. So into 1. Into 1 is don't worry with multiplication. So any number with 1 is nothing but same. So no need of writing again 1 there. Now you can observe the numerator. Tan plus sec minus 1. Tan plus sec minus 7. Are they same? Yes. Can I cancel? Yes. So this trinomial and this trinomial gets cancelled. What is remaining? So in the numerator I cancelled everything. Nothing is there here. This full trinomial and this full trinomial gone. So what is remaining in the numerator? Nothing is there. That is 1. And denominator it is secant theta minus tan theta. Is it not same what you have RHS? Yes. Now I have taken LHS and I proved that as RHS. So therefore LHS equals to RHS. Hence it is verified. So I said fifth question in fifth main and this example almost both are same, but the terms are little bit different. There in the numerator we replaced 1 by an identity. Here in the denominator we replaced 1 by an identity because you have in the denominator you have secant minus tan and in the numerator you have only 1. So that is your intention. Just look at the RHS and plan according to that so that you will get the answers. Now let us move for the sixth question. So he has given prove that square root of 1 plus sin A divided by 1 minus sin A equal to sec A plus tan A. So here again I am taking LHS. LHS is square root of 1 plus sin A divided by 1 minus sin A. You can observe LHS and RHS terms. In LHS you have sin, in RHS you have secant and tan. There is no relationship between sec, tan and sin here. So what to do? And one more observation you have to do. In the RHS you don't have square root. So the main intention is to remove the square root. So to remove square root I need square. Like for example, if I have square root of A, when that square root goes, when you have a square on A. So that is when power is 2, you can cancel square and root. So keep this in mind. Whenever you have a square root, you have to convert the terms inside the square root as a square of a binomial or anything. So like now our intention is to convert the numerator and denominator both as square of any term. So now for that, what I have to do? Multiply and divide it by the denominator. What you have denominator? 1 minus sin A. So now I am multiplying and dividing the opposite sign. So here you have minus. Like rationalizing denominator you learned in first chapter. So in the same way here you have multiply and divide with what you have denominator you have minus here, but multiply with and divide with by plus sign. So multiply and divide by 1 plus sin. So you have to multiply with the same term and also you have to divide this same term under the root. So this equals to root of 1 plus sin A by 1 minus sin A into, just now I told multiply 1 plus sin A and also divide by 1 plus sin A. Observe now carefully, in the numerator you have You can see in the numerator, you can observe you have 1 plus sin a into 1 plus sin a. When the same term is repeated twice, like a into a, what you will write? A square. So in the same way, when the same term is repeated twice, you can write that as 1 plus sin a whole square. So I got now square. So as I said, to remove the root or to vanish the root, you need square. So I got this square. Again, don't use a plus b whole square because our intention is to remove root. Now divided by, is it not like a minus b into a plus b, algebraic identity? So a minus b into a plus b equal to what? A square minus b square. So use that in the denominator. A is what? 1 square minus sin square a. So now this terms converted in this form, that is 1 plus sin a whole square divided by 1 square minus sin square a. Still what you can do? You can separate this root. You know that root of a by b can be written as root a by root b. This is one law which you have learned in 8th standard. Root a by b equals to root a by root b. So apply this and take square root for both numerator and denominator separately. Square root of 1 plus sin a whole square divided by, and keep root as it is. 1 square is nothing but what? 1 minus sin square a. And you can observe this root and square gets cancelled here. So write 1 plus sin a is remaining in the numerator. And in the denominator, still I didn't converted this as square of binomial. Square of binomial means it is square of the whole. Base should be common. But here only you have square for sine. I cannot cut this 2 and square root because it should be for whole bracket. So how to convert? As you know that sin square a minus cos square a equals to 1. Observe, sin square a minus cos square a equals to 1. And what you have here? 1 minus sin square. So when I write 1 minus sin square, it becomes 1 minus sin square, sin square a plus cos square a equal to 1, that is identity 1. So when I write in this form, 1 minus sin square a equals to cos square a. You can observe now, in place of 1 minus sin square a, I can replace by cos square a. Why I should replace? To cancel the root. So now let us replace 1 minus sin square as cos square a. Now you can see the square and root gets cancelled. Now write what is in the numerator? 1 plus sin a by cos. So just observe the RHS. Got the answer? No still. So what I should do? To get the second tan, so you can just separate this. Like it is like a plus b divided by c. You write a by c plus b by c. So split that. Now write. You can write that as 1 by cos a plus 1 by cos a plus sin a by cos a. Sin a by cos. Now you can see what is 1 by cos. 1 by cos is sec. Plus sin by cos is tan. So you can see this is your RHS. So I took LHS and I proved it as RHS. Hence that is proved. Now let us move for the 7th question. So what he has given, prove that sin theta minus 2 sin cube theta whole divided by 2 cos cube theta minus cos theta equals to tan theta. So think that if can I take tan theta and prove this bigger complex statement? It is impossible. So let us take again LHS and I have to prove as tan theta. So I cannot prove directly because there are no terms tan here in the LHS, but tan, you know that tan is nothing but sin by cos. So after simplifying this LHS, if you get sin by cos, you got the answer tan. So your intention is to simplify, where whatever identity you want to use it, but at last you should get sin by cos. Then you got the RHS. So LHS, take LHS, sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. You can just observe, here you have sine, one sine, and here you have 3 sines, that is sin cube. Here also you have 3 cos and here you have 1 cos. So can I take in the numerator sine and in the denominator cos common? So let us take sine theta common in the numerator. If I take common, this is nothing but 1 minus 2 sine square theta. Why square? Because of instead of cube y I wrote square because 1 sine I have removed out. Divided by, again take cos common. So when I take 1 cos out, here instead of 3 I have to write 2 cos square theta minus, here 1 cos is removed already, 1. You can observe now, almost your answer is over. Sine by cos is tan. You got the answer. But what I should do with these two? I cannot remove. So I have to make in such a way that both gets cancelled. So what to do for that? So write this, almost you got sine by cos is tan, right? Write it as this sine theta by cos theta is tan theta. Now this 1 you can write as 1, you know the identity. You cannot write whichever identity you want. You can write only because it is involved with sine and cos. So let us write this as sine square plus cos square. 1 can be written as sine square theta plus cos square theta. This in place of 1 I wrote the first identity minus 2 sine square theta, right, as it is. Divided by, again already sine by cos became tan. So now what is remaining here? 2 cos square theta, right, as it is, minus, in the bracket, be careful whenever you have minus sign, be careful with the brackets, minus, whenever 1 you have, again you write same formula, sine square theta plus cos square theta, close the bracket. Now what can I do? So here you can see the like terms you can simplify, you can cancel. You can see now tan theta, right, as it is, and you can see cos square, 1 cos square is there, so write as it is cos square theta, and you can see minus 2 sine square plus 1 sine square is nothing but minus 1. Minus 2 plus 1 is minus 1. So you will get minus 1 sine square theta. So no need of writing 1 there. What I did? Cos square, right, as it is, minus 2 sine square plus 1 sine square is minus sine square. So over this bracket is simplified. Now in the denominator you simplify in the same way. So but in the denominator you have a binomial with minus sign. First let us remove this bracket. So write 2 cos square theta. Whenever you are removing, remove the square bracket and put as small bracket. Minus sine square and minus into plus minus cos square theta. So now the denominator bracket is also simplified, but still I can see the like terms there. Tan theta cos square theta minus sine square theta, right, as it is, divided by, you can see here 2 cos square minus 1 cos square is nothing but what? Cos square. Cos square theta minus sine square theta. Okay, now you can see now whatever we have numerator and denominator with different terms, we got the same now after simplification. You can cancel this. So what is remaining? Tan theta. This is your RHS. In this way we proved, we take an LHS and we prove it as RHS. Hence it is proved.